Hey guys, welcome to Gear On For What. Today I've got something a little bit different for you. Today I'm going to be showing you how to animate a gearbox in Fusion 360, my new gearbox. So today let me introduce you to 149 to 1 3D printed compound planetary gear set built with nylon X filament. Excited? So before I get into the fusion thing, these gears do have a little bit of stuff on the side of them, but that's because I pretty much turned retraction almost completely off for this. So these will clean up really easy. This stuff just scratches right off. And there's the filament right there. It's pretty cool stuff. Really strong, really stiff for nylon. Anyways, I've got 9 of the 10 planet gears already printed, and I've got one more to do, and then, yeah.
So before we start, I might as well go and get rid of all this stuff that I've done here so that I could show you guys how to do it. The only thing I'm going to leave is something that's pretty basic. I just made a quick sketch here and extruded this part. I don't know if you absolutely need this, but I haven't thought of a way to get around doing it. And we'll get started. For now, if you'd like to follow along, you can click on this link on the channel banner, go to Thingiverse, and you can download the Fusion 360 project for a very similar gearbox by scrolling to the bottom of this page. And apparently I don't have permission. I'll have to fix that before I upload this video. Anyways, you'll be able to download this gearbox, and the CAD files for this you can download here too. Anyways, let's get started. So up here you could see a sketch of all the information I used to make this gearbox. So here's T-Sun 1, TS1 is 30, T-Planet 1, 10. So that would be in this first slice of the gearbox, or underneath ring number 1 and ring number 3 is the number 1 module, and then ring number 2 would be the number 2 module, and then ring number 1 and 3 have the same exact planetary gear sets in them. This is a compound planetary gearbox for those of you who haven't been to my channel. This is basically all I do stuff with, and this one I'm going to use. I'm going to try to make something really cool out of it. So I'm going to just start off by getting rid of everything after the timeline, because I just scrolled back to before I started the animation. Like I said before, I pre-made this part, so that's a pretty easy sketch to make. You just make a bunch of things and then a couple little things to connect them. And then first thing I'm going to do is I'm going to ground ring number 1, because that one doesn't turn. Stays stationary. And then I'm going to take and ground ring number 3. Same deal, it doesn't turn. And then I'm going to just hide both of those so that they're out of the way for now. And I might as well hide ring number 2 also. Okay, so now I'm going to take and I'm going to create a rigid, they call it a rigid group, between sun number 1 and sun number 3, because they are keyed to fit together. They don't turn independently. And that's just the first thing I'm going to do here. And then I'm going to take and make a revolute joint between an as-built revolute joint between this planet carrier and sun number 1 and 3. And then that will be position, will be center of the gearbox, which is the origin. There we go. Now you can see sun number 1 is turning. And then I'm going to create a joint, an as-built joint between this planetary carrier and ring number 3, which is grounded, and that will be of the same rotation axes. Okay, so now I've set this up to where this carrier can turn and the sun can turn. And there's a reason I did a joint between this sun and the carrier versus the sun and the ring and the carrier and the ring, and I'll get into that in just a little bit here. But first I'm going to use this revert button up here to put everything right back where it was before I started moving it. I'm going to hide this ring again, and I'm going to make another as-built joint between this planet here, if it'll let me grab it. Oh, I clicked on motion link. And I'm going to create another as-built joint between this planet gear and this carrier, and the position will be on the outside of this. Now when you start making joints between components and you have many of them like I do here, I have 10 planet gears, it's important to remember which one you grabbed first. For example, if you decide to grab the planet gear and then this carrier, make sure you do that with every single one. Otherwise, when you go to create a motion link between all of them, you'll have to keep deciding whether or not to reverse it to make them go the same direction. But if you always grab, say, the planet gear first, then you don't have to deal with that. So now I've got 3 joints. I've got one between these number 1 and number 3 sun and the carrier. I've got one between the carrier and the number 3 ring gear, which is hidden. And I've got one between this carrier and this planet gear, which is planet gear number 9. Just to demonstrate that. And then to demonstrate this joint. Oh. So I can go ahead and I can hide all these other planet gears for now. So there's a lot of fussy things with Fusion 360 and making joints that I discovered when I was doing this the first time. In a way that if I were to go and make a joint between every single planet gear and this carrier right off the bat, I might end up doing it twice. Because of the fact that sometimes you just have to stop and redo the joint to get them to work, which is hard to explain as to why. I've learned better that if you can get the joint to work between the planet gear, the sun gear, and the carrier, you're better off just leaving it at that until you get all of that working, and then you can go in and add in the joints for all the other planet gears. I'm going to get rid of this other sun gear, this number 2 sun gear. Okay, so this whole apparatus will turn as one piece, this sun gear number 1 and sun gear number 3. This will turn independently and this carrier will turn independently. And I will reset that back to where it was. So, if I go over here and I look at my sketch that I leave on all of my newer gear sets, I leave this sketch here. So teeth sun 1 is 30, that means that this gear here has 30 teeth and this other gear here also has 30 teeth. And then teeth planet 1 is 10, which means that this end of this planet gear has 10 teeth and this end has 10 teeth. So I know that when this sun gear makes one full rotation versus this, in reference to the planet carrier, that this planet gear needs to make, well, what would it be? 3 rotations. I can go ahead and do a motion link between those two. And I'm just gonna, I should probably name some of these joints before I start forgetting what they are. I'm gonna do animate joint. And like I said before, it is very important to have the joint for this sun gear referenced to the carrier, and then the carrier referenced to ring number 3, or just the ring gear in general. And that way, when you go to do a motion link, you're actually creating a motion link between 3 components in a really interesting way. So for the motion link, I'll grab the sun gear and I will grab the planet. Now, in a way, you're actually creating a motion link between the sun gear, the carrier, and the planet by doing that joint between the planet, or between the sun gear and the carrier. We know that for one rotation of this sun gear, if this carrier stays in the same spot, the planet gear needs to make 3 rotations. So depending on which one I selected first, and I can figure that out like this. Right now, the way I just typed in 10, for 10 degrees of movement on this will move 360. So to get that right, for 120 degrees of movement on this, now this one moves 360. And that doesn't look right though, because the teeth are overlapping. But if I just push reverse, now they're in the right direction. Now these 2 gears are meshing. And that is the first step in this process. So now if I turn this, the whole thing will try to turn. And if I just ground that carrier ring, go continue. Okay, now the sun gear is engaging the planet gear. Perfect. I'll unground that. Now I'm going to go and turn my ring back on, my number 3 ring gear. and use this revert position to go back to where everything should be. Okay, so I have a few knowns here. I know that this ring gear, judging by this over here, has 50 teeth, and this planet gear has 10 teeth. So I'm going to make another motion link between the planet gear versus the carrier joint, and then the carrier versus the ring joint. Now I know that when the planet gear moves 5 full turns, which would be, because it has 10 teeth and the ring has 50 teeth, when the planet gear makes 5 full turns, that would mean that this carrier needs to move 360 degrees, right? So for this, I'd do 360 times 5, right? This moves so fast, it's hard to tell if it's working, but it looks like it might be. Just in the wrong direction, I think. Yep. Okay, so that's working. So now you can see that if there was all the other planet gears in here, they would all be going around just like this one is. Okay, so now I'm going to bring in all these other planet gears and attach them to this first one with a motion link just between all the planet gears so they all move the same. And then I'm going to go revert position and just do an as-built joint between every planet gear and this carrier, always remembering to select the planet gear first. Okay, now I've got a joint between the carrier and every planet gear. Now I'm going to do a motion link between all of the planet gears, starting with the one that I originally animated. There's the first one. I'll probably fast forward through the rest of these. Guess I never put a joint at that one. Let me show you what happens if you don't keep your joints the same way. So I'm going to do an as-built joint for this last one that I forgot to do, and I'm going to select the carrier first, and then I'll select the planet gear, and then do the position. And you'll see that the carrier is actually orbiting the planet gear now because I didn't select it the same way. Now I'm going to do a motion link just like I did on all the other ones, and that joint is down here. Now you'll see that that planet gear is actually turning backwards, and I can fix that by just selecting reverse here, and then everything works out anyways. But it becomes an annoyance that's really not worth it. So just to show you, all the planet gears are animated. And if you're just animating a planetary gearbox, this may be the last step that you have to do. But this isn't your ordinary planetary gearbox. This is a compound planetary gearbox, which means that the middle of these planet gears have 11 teeth, and then this ring gear number 2 has 56 teeth. If you look at this sketch over here, so teeth on 2, 34, but then the teeth on the planet gear is actually 11, and then on the ring gear they actually have 56 teeth. So now that ring gear isn't actually included in this animation right now. If I just go through and show you that if I turn this sun gear, ring gear number 2 does not move, and I'll have to fix that. So now I'm going to take and do an as-built joint between ring gear number 2 and ring gear number 3. I'll do that as a revolute at the center of the gearbox. And ring gear number 3 is stationary, remember, so this will just be turning ring gear number 2. Okay, so to decide how much ring gear number 2 turns in respect to the rotation of this carrier, I have to look at what I know. And I know that when this carrier makes a full rotation, each planet gear engages 10 teeth to a 50-tooth ring gear, which means they turn 5 times to a full rotation of the carrier. Now those 10-tooth gears are attached to 11-tooth gears underneath ring number 2. I'll show you that. So they're a slightly different gear module, but so they're actually smaller. But there is 11 teeth on these planet gears here. And then there's 56 teeth on this ring gear. So to figure out how much ring number 2 needs to rotate with a full rotation of the carrier, I need to get out my calculator. 50 teeth on ring number 3, or 1, same thing, divided by 10 teeth on the planet gear, makes 5 full rotations of each planet gear in a full rotation of the carrier. If module 2 on the planet gear has 11 teeth, so multiply that by 11, that means that it's going to move 55 teeth in a 56-tooth ring gear. So if the planetary gears are engaging 55 teeth on a 56-tooth ring gear, that means that ring gear is actually going to have to move 1 tooth ahead. For example, if it was a 55-tooth ring gear and 11-tooth planet gears, the ring gear essentially wouldn't go anywhere as compared to ring gear number 3. So being 56-tooth ring gear and 11-tooth planet gears basically makes it so that it'll move 1 tooth ahead relative to where the carrier is. So the carrier makes a full rotation and the ring gear will move 1 tooth ahead. So what I have to do there is I have to calculate how many degrees are in between the center of this gearbox to 1 tooth of that ring gear. Okay, so if I take 360 divided by 56, I get 6.428. So I believe that's how much it should turn. And I can find out if that math is right by testing it. So if I do a motion link between ring gear number 2 and the carrier, I'm just going to get ring number 3 out of the way and enter in 6.42. Let's see if it's right. That looks right. And as you can see, the planet teeth are always engaging with ring number 2. So I'll bring ring number 3 back and ring number 1 back. And then you can see that that's working out. Okay, so next thing. I didn't do this in the original model, but I might as well do it now. I'm going to do something called Inspect Section Analysis. Find my origin. Oh, so now I'm going to take and I'm going to hook up sun gear number 2 to this entire animation of gears here that I can do. First I'm going to hide the planets, and I'm going to create another as-built joint, and I'm going to do this between sun number 1 and 3 and sun number 2. Do a revolute joint at the z-axis. There we go. For every 360 degrees that this sun gear moves versus this carrier, then this number 2 sun gear will move 10.6 degrees, I guess. And I don't know why the math is on that. I've tried to figure it out. I can't figure it out. So anyways guys, thanks for watching. For those of you who may have noticed that this is not a gearbox that I've released yet, you are correct. This is a 149.3 to 1 gearbox. This will be released in the coming weeks. This is one I designed specifically for Nylon X filament by Matter Hackers, and I'm currently in the process of printing it out.
Yeah, so here are the 9 planet gears I've already got printed, and these will be the same as the 160 to 1. They'll have a rod on the inside of them. They've all got a hole in the end. These are so light too. I mean, there's nothing to them. I mean, yeah. Anyways, hey, thanks for watching.